Hi friends, this is a series to cover the numerical portion of RBI Grade B exam. As you have seen, the number of numericals have increased in the past few years. Last to last year only there were only 5 or 10 marks of numericals, but last year there were more than 20 marks of numericals. So numericals have become very important in RBI Grade B paper. So let's try and cover most of the numerical part in this series. This series would have somewhere around 10 to 12 videos which would cover all the numericals ranging from bonds, securities, stocks, gap analysis, and balance sheet. Right? So let's start with a very core concept of finance, which is time value for money. So we have this very simple question, which is, sorry, are rupees 1000 which are with you today, 1000 which are with you in your pocket today, same as rupees 1000 you have after 1 year? The answer to this question, if you think about it, for you it might be same, but for a guy who is studying finance or for a guy who understand the money, it is no. The money which you have in your pocket is not the same in both the cases. So money which you have today is not equivalent to money which you have after 1 year, right? Though the quantum of the money is the same, we are talking about rupees 1000. You must be wondering, why is it so? Why are we saying that rupees 1000 today is not equivalent to rupees 1000 1 year hence? Let's see. So in finance, it is assumed that money today in your pocket is worth more money than the same money after some time, because the money, this money which is in your pocket, would earn you additional money, right? So what is he's saying? He's trying to say that, for example, you have 1000 rupees in your bank, right, or in your pocket. So you can use these 1000 rupees which you have today and invest it in 8% at 8% interest to earn that additional money, which is 80 rupees. So after 1 year, this 1000 becomes 1080. So this 8% is essentially the opportunity cost of the money which is lying today in your pocket, right? So this money would earn additional 8% to you, and 1 year hence, this 1000 would become equivalent to 1080. So today's 1000 is equivalent to 1080 1 year hence at 8%, right? So this is missing at 8%. So if it is 9%, it would be 1090. Let's go to the next slide. So that's how we come to the concept of present value and future value. So what we have today is the present value, right? So 1000 rupees was the present value of the money, and 1080 was the future value of that money 1 year hence at a rate of 8%. So you have to keep all these things in mind. So in our previous example, 1000 is the present value of the money. 1080 is the future value of money 1 year hence at 8%. So now if you look at the 2 year horizon, the future value of money 2 years hence would be 1160.64. So how would it happen, right? So 1000 rupees you invested at 8% for a year, it would give you 1080. Again 1080 would be invested at 8% to give you 1160, right? So this is nothing. If you remember, this is basically what we are doing is we are calculating compound interest, right? We are calculating the amount which we get after we use the formula of compound interest. So that's the relationship between PV and FV. PV is present value and FV is future value. So FV is equal to PV into 1 plus R by 100 raised to power T, right? So this is simple compound interest. So your entire finance would be based on this concept, right? Your entire investments, your EMIs, your retirement plans, all of them are based on this fundamental principle of compounding of money. So this is very important to understand. Let's take few example and you would understand it better. Before that, let's also understand the effect of multiple compounding in a year. So in the previous example, what we assumed is that the interest is compounded per annum, but it's not always the case, right? So interest, in some cases, the interest can be compounded quarterly, semi-annually, or even monthly. Let's take an example to understand it. So we have our PV of 1,000 rupees. That's what we are assuming. So case one is interest rate of 8% per annum. Future value after 1 year we have to find. So 8% per annum. When nothing is given, we assume that it's compounded annually, right? So we would use our formula, which is PV FV is equal to PV plus PV into 8%, right? Because it's after 1 year, so it's 1080. So this is one case where compounding is happening annually. So we have a case 2 where the interest rate is 8% per annum, the interest is the same, but it is compounded semi annually, which means that the you are given an interest after 6 months, and that on that interest further the interest would be counted. So let's see how do we solve it. So 8% per annum is compounded annually, which means that the interest is added after 6 months. How much interest would be added? It would be 8 divided by 2, which is 4%. FV after 6 months would be, so 6 months, hence the future value would be 1000 plus 1000 into 4%, which is 1040. This is, now this would again be invested, and this would be invested at again 4% for 6 months, right? So it would become 1040 plus 1040 into 4%. This is 1080.16, right? This is 0.16 more than case 1. Hence, if interest is compounded multiple times in a year, the future value becomes more. So can you see the power of compounding? If the number of periods of compounded increases, the final future value also increases. So that's the power of compounding. So what is the modified formula of our future value? It's FV is equal to PV plus 1 into 1 plus R by N, where N are the number of times compounding happen in a year, divided by 100 raised to power N into T, right? So that's the new formula of compounding, and this would be used in various examples. So future value of, now we come to another concept. So this is, what we are doing is we are doing a future value of one investment. So we have invested something today, and we are looking at future value of that particular money which we have today, right? What is also interesting is to understand that we can calculate future value for the series of investments, right? So for example, I invest rupees 1000 each year in a systematic investment plan for a period of 5 years. That is, I pay SIP from 2001 to 2005. It is known that average rate of return of this investment is 8%. What amount will I get in 2005, right? So from 2001 to 2005, I keep on putting in money, right? So, and I would withdraw the money in 2005 itself. So that's the question. So now, what would be the future value of my investments, or what would I get after 5 years? So here we are investing 1000 each year. First year investments, 1000 would be invested for 4 years. So 2001 to 2005 is 4 years, right? Second, so FV1 is this. The second year investment is done for 3 years. So it is this. And FV3 is this, FV4 is this, and FV5 is this. So finally here we are also putting in 1000, but then we are withdrawing the money. So the total future value would be sum of all these, right? What we are trying to do here is arrive at a formula. So the formula for the future value of series of cash flow, if you can look at it, it's a geometric progression, right? Thus the FB in the last year can also be written as FB is equal to this. Again, it's a geometric progression. Using the formula of GP, we can write FB is equal to A, where A is the annual investment, into 1 plus R by 100 raised to power T minus 1 upon R, right? So this is the formula which you can use in various examples, but you have to be very cautious with this formula. So what is happening is the last investment is not not being invested for any time, right? So as soon as I pay 1,000 rupees in the last one, I'm talking about this one here. So as soon as I pay this one, I withdraw the money. So this is not being invested at all, right? So these are the investments, right? So understanding this formula further. In the previous example, we have invested assumingly from January 1 to January 2005, right? We pay our last installment in, sorry, we pay our last installment in 2000 and January 2005, and then get the final money, right? So in January 2005 we pay the installment as well as we get the final money. Note that this formula is not applicable if we remain invested in 2005 as well. In that case, we need to use the individual future values. So in the last scenario, the amount invested annually and the time period of investment was the same, right? So we are investing the amount which is the annual premium each year for the total period of our investment. So we are investing for 5 years and we are getting the returns after 5 years. But this formula is not applicable in many other scenarios. So one of the scenarios is I invest rupees 1,000 every year for 3 years in a policy whose duration is 10 years, right? So now the duration of the policy is uh, 10 years, right? This is important to understand. So in at year 1 I invest 1,000, in year 2 I again invest 1,000, and in year 3 I again invest 1,000 at 9%. So what will I get after 10 years? So let's see the solution for it. In this case, we cannot apply the formula directly. We can find the future value of each year's investment and then add them like this, right? So future investment of our first tranche would be this, second would be this, and third would be this. If we add it, we get this. So this is simple compound interest wala formula, right? There is another way to do it, slightly complicated, but nevertheless it's important to understand that. Alternatively, we assume annuity formula for 3 years. So annuity formula was the previous one where we were doing this thing. So for the 3 years, we are investing for the money, right? And post that, for example, we started this in 2001, we do it for 2002, and in the beginning of 2003 we again invested 1,000, right? So at the beginning of 2003 we add these three stuff, right? These three, and we get a value, a future value at that point of time. So this future value is further invested for 8 years, right? And we apply the future value formula, which is 3278 into 1.09 raised to power 8, which again gives us the same answer, 6531.81. So if you see, the second approach is slightly complicated, right? It's slightly complicated, but nevertheless it's important to understand it. So you can, I don't recommend to use use the formula everywhere. Rather use the very basics, which is the compound interest basics. So now what till now what we were doing was we were finding the future value of our present income, right? Or the investments which we do at one particular time. Now we can also do the other way around. That is, we know that we would get, let's say, in a fixed instrument, we would get rupees 20,000 after 10 years, right? So the question would be, at what price should I purchase that security, right? Now imagine that I need to pay a tuition fee of rupees uh, 1 lakh after 5 years, right? So I am planning to go for a foreign MBA, and I have to pay rupees 1 lakh after 5 years. What amount should I invest at 9% today, right? So I'm just planning for the future, and this is thus the future value. This is the value 5 years hence which I want. So how much should I invest? So this is simple, right? Future value is 1 lakh, and rate of interest is 9%. So we would simply apply this formula. Fv is equal to PV 1 plus R by 100 raised to power 5. So we would get PV is equal to 1 Fv upon 1 plus R by 100 raised to power T. So this is the formula of present value if future value is given at a given rate of interest. So let's take another example. Suppose a fund gives me rupees 1 lakh after 10 years. Somehow I need the money after 4 years at 9%. What will I get? This is nothing but we are finding the value of our investment after 4 years, right? So PV today, so future value is given after 10 years, which is 1 lakh. We have to find future value at 4 years, or we can also find PV today. So here is how we solve it. So firstly, we can find today's PV, which is this, and then we can say FB4 would be today's PV into 1 plus 9 by 100 raised to power 4, which essentially becomes 1 lakh divided by 1 plus R by 100 raised to power 6. So this is equivalent to that we are investing some amount FB4 at fourth year at 9% to get a return of 1 lakh after 6 years, right? So this is just saying that. So this is equivalent to finding a PV of 10-year asset after 4 years, right? I think it's slightly complicated. I'll again repeat it. So if you see, the end result becomes 1 lakh divided by 1 plus R by 100 raised to power 6. So this is difference of 10 minus 4, right? So this means that what we are trying to find is the present value of our investment after 4 years, right? So this assumes that we have some amount which we invest after 4 years, and it should give us a amount of 1 lakh after 6 years, right? So this is how we do it. So present value of series of cash flow. Again, this is equivalent to finding the future value of series of cash flow. Let's take an example and understand. Suppose you want to purchase a security which promises to pay rupees 1000 each year for 5 years, which with first payment 1 year from now, right? With first payment 1 year from now, how much should you pay for such a security? The rate of return is 12%. So the concept is very similar to the future value, right? So after 1 year, I'll get 1000 rupees, but it would be equivalent to 1000 divided by 1 plus 12 by 100. The money which I get after 2 years would be equivalent to 1000 divided by 1 plus 12 by 100 raised to power 2. Similarly, after 3 years, we would get 1000 divided, the present value of it would be 1000 divided by 1 plus 12 raised to power 12 by 100 raised to power 3, and so on. So if we add, we would get the present value of today. And if we again, you can say it's a GP, and we can find a formula for this. So this becomes PV is equal to FV into 1 minus 1 by 1 plus R raised to power T by R. So if it's compounded annually, then this is the formula. If it is compounded multiple number of times in a year, then the formula would be R by N and NT accordingly. So the question is, what if different cash flows are coming in each year? So let's assume I invest, let's assume that in year 1, your investment gives you 1000, in year 2, it gives you 500, in year 3, it gives you 2000. How much should be the present value? In that case, you cannot apply the formula. You have to simply apply the concept, which is FV1 by 1 plus R, FV2 plus raised to power divided by 1 plus R raised to power 2, and so on. In this case, cash flows are different. The formula cannot be applied. Then there is another concept, which cash flows are better. So let's assume that we would get rupees 15,000 in 3 years from three of the investments. First investment would give you this ways of cash flow, second would give you this way of cash flow, and third would give you this way of cash flow. So which security should you invest in? So which is the best security according to you? Essentially, the security which gives you more cash flows early on, right? So if you see, it's giving us equal cash flows in all the 3 years. In this, the first cash flow is quite higher. It's almost double than this, right? Then the second cash flow is higher than the third one. In this, the first cash flow is higher than this one, but it's not higher than this one. The second cash flow is high. Here, this is higher. But first cash flow is the most important. If you are getting the maximum cash flows in year one, then that investment is the most convenient one. So we know that as the number increases, the present value of cash flow would decrease, right? So look at this. As the years increases, the present value of cash flow would decrease, right? So in the year one, the cash flow was 1000 divided by 1.12. Here it was 1000 divided by 1.12 raised to power 4, which is way less than year one's cash flow, right? So that's what he's trying to say. So a security which gives you maximum cash flow in initial years is the best. In this case, it is security 2. It can also be validated through the formula. So PV1 is 12434, PV2 in the similar way is 13078, and PV3 is 12907. So in this way, we can see that PV3 is the most beneficial. So hence we have covered the basics of our time value of money. It would be more than sufficient to do various numericals from securities, from bonds, from fixed market instruments, etc. We would be covering more concepts in the future topics. Thanks for watching this video and all the best for your preparation.